before I move on to the shaft, I want to go ahead and take care of a couple of fillets in the interior corners there, or exterior corners. I'm going to pull, select, control select, go into the fillet, and if we were to make a 8mm, I think 10mm would be okay on that one. So we'll go ahead and include that one. And I rolled back so that it wouldn't affect the saved bodies. And then we can go ahead and save it. So I've been looking at the transition fits and the locational fits for the shaft, and the charts don't use it enough to be really proficient at it. So I'm going to do a little bit more research before I jump into that one. When this updates, I should see the fillet come over, and in effect this becomes my subassembly. So maybe the naming convention, the cam follower, really doesn't apply to this base. So at this point I don't have any references going away from this as in a top down, but I do have the relations or the references coming in externally through the parts from the multi-body. So I'm going to save all and close that out. Go ahead and see what else is open. So the housing is open, and something else that I haven't really looked at is chamfers and fillets, and how much of the edges and geometry would affect the interior shapes being able to fit those items together. So pretty much just going to back this out. All right, and then it comes to the assembly, and we already have a cam follower base. So before I get too carried away with the naming, see if I can find my apparently not. I was going to look for my SolidWorks Explorer. So in that case, okay, so I've gone into my SolidWorks Explorer and I'm navigated down to the folder, and I'm looking at the cam follower assembly file. If we look at its properties, then nothing's been addressed. References are, I trust them about maybe 80 to 90%. The file references in the assembly are much more reliable as to locations and what's being referenced. And then the where used, nothing really coming across. So this is a fairly new open document, so not sure what it was looking for there. All right, and then we can preview. So one of the things that I was looking at is if I go to rename this, and I rename it out of the SolidWorks Explorer, then any of the files that include virtual components and documents. So I'm just going to rename this assembly to the cam follower base. And this is kind of my check that I'm not going to lose any of those links. And then everything kind of updates, and we can jump back into SolidWorks. Alright, so when I go back in and try to open up the cam follower, it's not going to be there because we just renamed it. So if I pull up the base, then we'll navigate back through and see if nope, didn't come across. So if I expand out the CF base, which is the start, alright, so apparently those are still loaded in memory from prior, so don't have to get into that. So what I'm looking for is this to be a subassembly as a complete unit drawing package, and then the cam, the shaft, any of the retaining geometry would be in that other subassembly. And then of course the cam follower itself will, the roller up top would be a separate subassembly. Alright, so if I come in and pick the bearing face and go to the bearing face, we jump back into inches, but 1.97 should put us at 50 millimeters. So I'm going to go ahead and close this, let it save, pick up a new metric part, and again I'm going to be creating a revolve. So the front plane, open up the sketch, go center line, infinite length, horizontal, place that on the origin if we're to lose any of that. Alright, so we did 16 millimeters off of the front. I just looked at that bearing too. I didn't jot it down as to what its size was. It was still pretty good size though. So, and then we're coming back to 17 millimeters for the through, and this is where I need the class of fit. And then there's going to be a jam nut, and from the jam nut I need something that's going to drive into the coupler, and then we're going to close the whole thing off. Alright, so I've started putting in some dimensions. So 16 millimeters on the face to enter, go into the cam, and then well, would like to have something that is going to contact the bearing face but not overrun it too much. So if we go, well, let's just see, the 30 or 31. 30 would be 1.18. Getting up to 1 1/4. And there again, let's go into the documents. I may have to add this to the template if I do it enough. The dimensions, and we'll set the dual dimensions, and we'll set them to the bottom. Alright, so 1.22. Nice thing about that is if I start off with 1 1/4 stock, then I'll be pretty close to turning it to size and be able to control that OD. So not a critical dimension, but do want to be aware of it. So thickness of the cam was 15 millimeters. And then the boss that we're kind of replacing is 5 millimeters. And the distance between the bearings is 50 millimeters. And my concern on the tolerancing is that I have enough of a compression against that I can actually load and keep the in and out movement to a minimum. Let's see, this was 17 millimeters for the through, so just a little bit bigger than the shaft. And then this is going to end up being a 16 millimeter by 1 pitch thread. And then the shaft, let's start with 1/2 inch, so 12.7. Alright, and then lengthwise, I'd have to look at a jam nut or pick out a piece of hardware on that one. So let's start with 20 millimeters, and we'll see how far that goes. I did start to look at the couplers. So a clamping precision flexible coupling shaft. So right now I'm looking at these as metric. Let's see, they do go 10 millimeter, 11, 12, 14. Alright, overall length, and then OD. So they start getting pretty sizable. Imagine like the 1/2 inch. So maybe we will go with just a 12 millimeters so we can stay metric across the board. And then 12 millimeters to inch, and then 12 millimeters to 12 millimeters. Alright, so that would be the concern, is if I have a 1/2 inch. I mentioned the NEMA 23, but those were positioning steppers, so we're going to have to look at a different series of motor. So I think I could probably get away with the 12 millimeter by 1/2 inch as a starting point. A little spendy, but Let's see, what's the next one down is max torque of 58, max torque of 80. Well, I guess to be on the safe side, RPM of 6,000. Well, let's go ahead and spec in the more torque and and see if we get that the calculation. So one of the things with the 2 kilograms roughly that is rotating mass, I'd have to sit down. We don't have an upper limit on our RPM, and that's going to be kind of based on the motor. But if we were to say an 1800 RPM motor, and with a with the 1/2-inch shaft, then this would get us there. Let's see. Then I also want to download the part, and we'll need to pull that over at some point to get it into the assembly. All right. So jumping back into SolidWorks. Maybe. SolidWorks is still thinking. See what all I have open here. Well, if I didn't crash something jumping in and out of it, well, this could be a good spot to pause then. Okay, I think I got it recovered. I was looking for then kind of the depth that the shaft could go, but we'd go at least 1 times the diameter. So 1.5 would be 18 millimeters. So that would be a good starting point. Then we could see what we can do. So for our critical faces, then we would need the alignment to the shaft through the bearings, but the bearings really front and back. I could almost put a little relief in there and say, just in this area. But with the machining processes and the potential for taper hanging out, what are we at? 2, 3, almost 4 inches. That keeping that on line. So I may want to put a center in there as well, so that we can support it while we're turning the geometry. All right, so 360 degrees of rotation. Sketch is open. Oh, and I had one pick, so it didn't like the line that I was measuring. All right, so that gives me a basis of the shaft. All right, so I'm thinking I will probably go ahead and put the keyway. I think we had a 5x5 keyway, and I don't know that I need to have it fully engage. So from the front plane, I'd like it on the top, at least from the top view. So if I do a section view, let's see, we could do a section view from the top. Yeah, maybe we will go front plane. And then to the cylinder, going into reference geometry, create the plane. And I want it parallel. And we create the geometry. So there's 2 ways to create the keyway slot. One would be a Woodruff cutter, but it's going to have such a large diameter that we're probably going to end up cutting a lot into the flange. And so since that's not desirable, I'm going to open up a sketch on the geometry, and let's just go ahead and create the rectangle, and we'll set that to make the midpoint. This is going to be then 5 millimeters. And I don't want to get rid of the end of the rectangle just yet, so we'll go to construction line, and don't like the way that one pulled out. Okay, and then we'll see if we can go tangent to the outside. Alright, so for 5 millimeters by 5 millimeters, we're a little bit high, and it's going to kind of also depend on the broach. So since I'm not quite at that location, I might have to do a pre-sketch. Typically the key is, I believe it's centered, so we can go back and find that keyway diagram. But the midpoint is on the circle, and then half is above and half is below. Alright, well, I'm going to go ahead and put it in the extrude cut, and we'll make it about 2.7. So 2.5 plus another 0.2 millimeters. That should give it a little bit of relief. Alright. Okay, so we will go with the shaft. And I'm not sure that I want to create a new folder for this. It's going to be the piece, the key. We already did the cam. What I don't have in here then is the retaining, because we're going to put the cam on, and then this seats up against the bearing. This goes through the bearing. The threaded portion goes into for the jam nut, and then that goes to the coupler for the motor. Alright, so if I go to an S key and we pick up the hole wizard, and we can stay with the M6 by 1. The issue here would be, of course, that can I find a fender washer or washer that is large enough? Don't think it needs to be up to next. Let's go with a blind in condition, a little bit more than 5.4. Let's see what the defaults are. 12 and 15. Okay, I can do that. I'll go ahead and accept. And then we could try the thread, but in 2017 the thread tool, let's see if it's even here, the thread wasn't that good, so and I don't really want all of that extra geometry. So picking the inside edge, I have cosmetic thread added to my command manager, but that's not going to be common. So insert annotations cosmetic thread, and this is going over to ANSI metric. We're picking the M16 by 2. I think I was saying M16 by 1. Oh, M6 by 1. Anyway, we'll go ahead and tell it up to next and see what it generates. Now, I did not put a relief on this, so that would be the other question or item is, do I need to put a relief in here for the thread? It would not be a bad idea. So that being the case, let's open up the sketch. Now, putting that in tends to create a stress riser, but it depends on the geometry of our grooving parting tools. So if we have a little bit of geometry, I'm going to go with the 3.18. So 0.125 inches is a standard grooving tool. And then if I was to do 1.5 millimeters, I think that would get me below the thread. And then that would allow, and again, depending on how much I need for tolerance, to press up against the bearing. So I have a feeling I'm going to be shortening this by at least 0.5 millimeter so that it gets interior of the thread. All right, so let's go ahead and revolve cut. So the sketch was still selected, so I can go right into revolve cut even though I technically closed it. And then would like to have a few radiuses in there, but not ready to call those out just yet. All right, so I'd have to check the tool geometry that I'm thinking of to get that in place. All right, so critical geometry, we're going to highlight in red, and we'll go with the faces. And if we go with bright red, then those are the items that I'm going to be focusing on as I put in my run out and my total indicator run out. Alright, so let's go ahead and create a new assembly. And we'll switch it over to metric. Now, I guess we'll go ahead and grab the shaft since it's there. I'm okay with the position. We'll hit OK. And then, so I'm doing most of geometry and metric, so we'll stay with millimeters, grams, and seconds. I'm going to insert a component, existing part, browse to the cam. Right, and then we will set to concentric, and then we will see if we have cooperation to go coincident. Okay, so far so good. And then the face and coincident. Alright, so I shortened that up enough. So it was either 16 millimeters and I made it 15 millimeters, or we need something that will pick up the geometry. Alright, so going further on, we have the coupler. I'm going to need to find a jam nut. So let's see if the toolbox is open. So we'll activate the toolbox, give it a chance to catch up. And go into the design library. Don't have, oh, there it is, the toolbox. And we'll go with ANSI metric, find a hex nut, flanged, hex jam, and yeah, I think I would like the jam, so I'll go ahead and place it. And it should see the M16 by 2. Right, and if it doesn't completely meet, then we'll go ahead and apply the coincidence. Right, so that brings it up into, and so we're gonna. So I'm gonna have to kind of think: do I want to put a regular washer and then a button head, or the socket head and more torque? All right, so we're going to save this. There's more items. Oh yeah, I'm going to put in the cam follower. And we'll do that as the shaft assembly. Okay, and we're going to see what the coupler looks like. So I should be able to pick that one up. Aluminum helical. Alright, so one of those, and it's not uncommon for these to come in with sketches shown and have to go through and hide. Alright, so however they were built. Okay, so on the diameter we have the radius of 6. Go ahead and make that concentric and pull it back just a little bit since it may have twisted. So that's the 6.35. So what that tells me, I need to go identify the mate, and we'll flip the mate alignment. And then don't really care about that circle. So 6 millimeters on the radius, and then we'll bring that up to couple. All right, so it goes to coincident. All right, so the thing with the 80 inch pounds, I would have to go through. If this doesn't flex enough, then it would still be transferring all of that energy into our motor. So still in the back of my mind, that selection, but it gives us something to reference and an idea of where it's going to sit in relation to the motor. All right, so one of the benefits, or one of the possibilities of going with the with a belt or some kind of mechanical drive is the belt takes up some of the compliance in this coupler. But then we're talking a set of pulleys and a belt and tensioner, and so if this still works out to be a little bit better. Alright, so the jam nut comes up. We probably need to put a lock washer underneath it, but that gets me at least started with it. Alright, so I'm going to save all, and then bring this into the next level assembly. And I have the shaft, I have the items, but really I want the base and the cam follower base assembly specifically to be the first component. All right, and then when we insert the next, then I have the shaft assembly. Well, that was actually a pretty good jump, except it's backwards and not going to cooperate there. So it looks like it's trying to rotate. Maybe we'll rotate about Y. Nope, it's still wanting to get in there. So there's like a mating reference, but let's see if it goes one more time. And I hit Tab. Nope, it's not going to cooperate the way I want it to, so we'll go back to our geometry. Alright, so to the bearing, and that becomes concentric. To the bearing face, we have the interior of the flange, and then, did I miss something there? Well, it either popped up and I didn't catch it, or we're going to go coincident. Alright, so that's looking pretty good. Probably don't need that much. And then whatever we're doing out here for a motor, that's a completely different mount. Alright, so if this is the biggest we have to contend with, then we'll call that good. Alright. So I'm at the top level assembly. Let's go ahead and save this, and then maybe this one becomes the cam follower. Hopefully I won't have to rename too many more times to figure this out. Alright, so we save it, and then I'm ready to do the bearing and the actual follower as a top-down assembly.